Hello, kiddos. So we're going to go over the different types of chemical reactions. So all this is labeling and naming specific types of chemical reactions. So the first one we have is a synthesis. So if you know the word synthesis or have heard it before, it's used to bring something together. So if you're writing a synthesis somewhere, you're bringing together your ideas with the content. If you're synthesizing something, you're bringing it together. So on your notes page, you just need to name it synthesis, and it means come together. Feel free to pause this video so you can take a moment to write that down. So here's an example of we're taking our compound or molecule A and adding it to compound molecule B. So the reactant side, we're going to see it be on the plus, we're going to see a plus on the reactant side. Then when it goes through the reaction on the product side, we're going to see A and B together as one compound. Here's an example of a synthesis reaction, carbon dioxide. How we get carbon dioxide, we've got to have an atom of carbon and a molecule of oxygen coming together to create carbon dioxide. Same thing down here. This is a little bit more difficult one, a little more complicated one, but we're taking one compound and another compound, adding them together to create one compound. The next type of reaction is a decomposition. Decomposition, anything that decomposes or is something that's breaking down. So it's the opposite of a synthesis reaction. We're starting with one compound and breaking it down into either two compounds or two molecules, two different things. So the way you can tell this one is we start with no plus sign at all, but we end with a plus sign. So we're starting as one whole unit, one whole group, and then breaking it down into two different groups. That's a decomposition. It's breaking it down. So take a moment, pause this video again, so you can write these notes on your paper. An example of decomposition reaction. We start with zinc, carbon, and oxygen all together, but then we break it up into zinc and oxygen and carbon and oxygen. Again, what you're really wanting to look for is on the reactant side, there are no plus signs. Then on the product side, there are plus signs over here, going from one group to two different groups. Same thing down here, going from one group to two different groups here. Right? The next type of reaction is called a single replacement. Okay, and so that word single, that just means one. And then replacement, literally, we're just replacing something. We're taking it and replacing it with something else or moving into something else. So a single replacement, and the definition is one element replaces the other element in a compound. So let's look at this example up here. We have the compound that has element A and element B together. Then we have a plus sign, and we have an element C here. Element C is separate from A and B. Well, once it goes through a single replacement reaction, A and C are now combined together, and B is all by itself here. Again, these are a little more difficult this one's a little more difficult to identify just because there are two plus signs, but what you got to be careful of is just identifying the elements and identifying the compound together and seeing how they replace. One silly way to help you remember this is you can think about it in terms of personal life, maybe. You have your best friend A is dating somebody B, and then you are here C, you're kind of the third wheel. Well, then all of a sudden, uh-oh, you trade places. You and your best friend are all by or together. You and your best friend are back together, kind of leaving the one out, individual, single. All right, some example here. We start with potassium as the single, and then we start with sodium chloride, sodium and chlorine as the compound here. Then what's going to happen is sodium is going to get dropped by chlorine and replaced with potassium. So Cl is now bonded with potassium, the single one, and Na is now the single one all by itself. All right, same thing down here. Na and Br are bonded together. Cl is the single, but then when it goes through a single replacement, NaCl is now the bonded compound, and Br is all by itself. All right, and then we have one single replacement. Now we have a double replacement. The double replacement is each compound switches one element with the other compound. So this one, the way you look for it is you just have four compounds. That's the way I would determine this one. For or two compounds on the reactant side, it would be elements A and B, and then elements C and D bonded together. And then they're just switching one of their elements. So example, A and C would be bonded together, and then B and D. So again, just four total compounds all the way through. All right. This example would be barium and chlorine. Then you have magnesium and sulfate here is what, or not sulfate, sulfur and oxygen here is what we're looking at. This would act like one molecule here. So then Ba switches Cl out for SO4, and then Mg switches out SO4 for Cl. So they're just switching partners. They're switching their buddies there. All right, and those are the four different types of chemical reactions that you're going to be responsible for understanding and being able to identify, and that's what your next activity is going to be on.